Dear colleagues and friends, first I'd like to thank warmly IAAS, and more specifically Mark Skinner, for inviting me to contribute today to this very important and timely workshop. My name is Christophe Bonnal from CNES, French Space Agency, more precisely from Launcher Directorate. I've been in charge of space debris activities since 1987, which probably makes me one of the oldest debris still active in Europe. I'm French delegate to IADC, ISO, ECSS, where I have the pleasure of working with numerous colleagues who are present today. I'm also in charge of space debris activities at IAA level, International Academy of Astronautics, and of space traffic management activities at IAF, International Astronautical Federation, which is the frame of my talk today. Around this virtual table, we are all very aware of the evolution of the orbital situation since Sputnik in 1957, but more specifically, these last 5 to 10 years with the emergence of the so-called new space. The last count identified 21,104 objects in the spacecraft catalog, which, by the way, does not include a large part of the population for defense reasons, out of which less than 12% are active spacecraft. This situation raises numerous concerns for near future, mainly a large number of small spacecraft, CubeSats or larger, with no collision avoidance capacities, very large number of medium-sized spacecraft constellations, new radar capacities leading to an increased size of catalog, not always associated with an increase of the accuracy of the ephemerides. So there is definitely a need for coordination at international level, or call it management, or call it control, as was proposed already by Nagatomo in 1971. We will need to discuss these terms. To cope with this challenge, or at least contribute to the worldwide effort, it was decided to organize a dedicated working group between IAA, IASL, and IAF, with the final goal to come up with comprehensive approaches and proposals for space traffic management in order to promote the safe use of outer space and shared at worldwide level. In that frame, it was proposed to have a dedicated IAF technical committee. See here the front page of the Memorandum of Understanding between the three organizations. The IAA part is headed by Corinne Jorgensen, the ISL one by Diane Howard, and the IF part is co-chaired by Diane McKnight and me, Serge Platard acting as the secretary. We have three main areas of work ahead of us. First, the improvement of knowledge of what we have above our heads. Second, the improvement of how to use this data. Third, the framework under which we should work at international level. Let's start with the knowledge of orbital population. First, we need to improve the existing means which are necessary to feed our catalogs. We need new sensors, radars, telescopes, of course including private networks. We need to study and promote new systems such as orbital sensors, laser detection. By the way, you may have noted the recent announcement by our ESA colleagues of a laser detection system functioning in full daylight. We need to improve the trackability and identification of small spacecraft. For instance, CubeSats should be equipped with corner reflectors or ID tags. We are working on such IDs at IDC and ISO level, which will probably end up with a specific standard. Data fusion of ever-increasing amount of information is critical. Merging such inputs from a wide diversity of sensors require dedicated standards concerning formats, including time tag and so. This is progressing rapidly, mainly under the leadership of Daniel Trogi. Second, we need to drastically improve the orbital data accuracy. Drastically meaning by a factor of 10 or 100. If I may just remind you an anecdote, so we at CNES in 2019, we had to deal with 3 million conjunction data messages. I think that's 1 every 15 seconds. Altogether, this led to 26 collision avoidance maneuvers. So that can give you an order of magnitude of the level of false alarms that we have today. So for this, we need definitely to improve the computation means and filters, maybe change methods somewhere, use of starry background and optical observation, maybe use laser ranging from ground or from orbit. You may have noted that we published laser ranging from orbit together with two American teams, colleagues, and one from École Polytechnique. Third, the improvement of the UN registration following the Convention of 1974. Remind you that any object which goes into space shall be registered at UN level. Unfortunately, this is quite badly followed, and so we need to improve the compliance to this. For instance, we suggest to have a systematic pre-registration before each mission of all the objects. So pre-registration means it's just we fill the paperwork, it's ready, and once the object is in orbit, then we do the full registration and send it to UN. Last, we need to understand how these SSA databases and catalogs can live together with, despite all the hurdles that we know, legal, political, military. Then we need to improve the way we're using this data, so the orbital operations. First, we have to improve the collision avoidance process in order to reduce the rate of false alarms and gain confidence that undetected collisions will be globally remote tomorrow. We need new methodologies to face the increase in size of catalog. Though I'm not an expert at all in the field of artificial intelligence or big data or stuff like this, but if it helps, they are more than welcome. We need to share this methodology for probability computations and associated thresholds. The first through technical reports at ISO level, for instance. The second thanks to standards, at ISO as well, shared at worldwide level. Second, we need to adapt for future operations, such as optimize the ascent and descent and choose the preferable strategies. For instance, this is something which has been done very wisely by some operators of large constellations, where they launch at very low altitude, they check the functioning of their satellite before reaching the operational altitude. This is something which is good and which could be specified in a more standard way. We can have dedicated index, a bit like the fridge index that you have. So this is something on which my colleagues from ESA and CNES are working quite a lot, and I think that we'll have a dedicated index published to a specific standard quite soon. Then we have space tugs, in-orbit servicing, refueling operations. Wait, these are already today with the MEV operations, and so we definitely need to understand how to be sure that it works correctly. One question mark that we still have is related to suborbital activities. Should we include this in this reflection, or maybe not, maybe just deal with it at national level? Third, we have to prepare ourselves for future activities. Active debris removal to avoid statistical collisions. Okay, we remove 5 to 10 large debris, the worst debris every year in order to stabilize the population. We know this very well because we've been working on this for 15 or 20 years now, and it raises plenty of questions. How do you approach a large derelict object which does not belong to you? And typically A catches B and deorbits it. Doing so, it impacts C. How do we prepare for it? JCA, just-in-time collision avoidance, is a little bit different. It's a tactical action by nudging a large debris to avoid a predicted collision with another debris. You have detected that within 48 hours you have a reasonable chance, let's say a probability above a given threshold, to have a collision between two large debris. So there are some ways, which are not science fiction and which have been published quite a lot, to avoid the collision between the two objects. So for this, once again, it requires dedicated standards, dedicated operational abilities. Third, a little bit in the same way, it's what we call the LDTM, Large Debris Traffic Management, which consists in a light nudging of debris permanently to maintain a stable situation. It's really the shepherd dog keeping a good eye on all its herd and correcting it when necessary. At national level, we need to have as a priority a good set of debris mitigation texts, updated, adapted to the current situation, and effectively applied. So today the good news is that we do have a good set of debris mitigation guidelines, and so through IDC, UNCOPA, CCSS, ISO, but also at national and agency standards, guidelines, recommendations, best practices, charters, law, you have all the family. The good news here is that we all share the same concerns, the same requirements, and so there is globally a very good coherence among all these texts. Of course, there are some differences, but we're working on this, and so we can hope that tomorrow we'll share the same text, basically. Unfortunately, the compliance level today to these current rules and guidelines is very low. And so it's even quite a surprise. We're not sure to understand why it's that low. So we need for more education. One thing would be to have a systematic inclusion of ISO standard in any contract. Okay, you order a new satellite, so you put in your contract that you want the ISO 24113 to be applied. Same thing for the launcher. In my wildest dream, I even imagine that tomorrow you will be able to say to an operator, hey, don't go and launch with him. He's not even ISO 24113. It could be a very good argument. We could imagine to have a compliance file systematically prepared before any space operation. So compliance to ISO or to national standards, of course, depending to the authority which is applicable in this specific case. We could imagine to have a naming and shaming at co-post levels. This could help for more education. You know that we already have this naming exercise at IDC level, where every year ESA and CNES publish the performance of the various countries, the various operators, both in LEO, MEO, and GEO. Today our guidelines are not yet adapted to new practices. We have plenty of ongoing actions, mainly at agencies, IDC and ISO level. And the good news is that there are dedicated charters among space operators. For instance, if you look at the Space Safety Coalition, where Daniel Droge has been very key for this document. This is an excellent document and really an excellent initiative. Now, a few concluding words just related to the IAF Space Traffic Management Committee. So first of all, the terms of reference are under consolidation. They have been widely distributed, widely commented, amended, not converged yet, but it's ongoing. Membership is open, even though we have plenty of potential members already. One thing which is important to understand, it's not the place to invent new things. There shall be no duplication, of course, with the standardization efforts, ISO, ECSS, or national, or agency. There are no duplication with the ongoing working groups at AIAA, AASS, or European Space Policy Institute, Space World Foundation, or Air and Space Academy level. There is no duplication as well with ongoing actions at on orbit servicing, rendezvous and proximity operations, and close proximity operations. What we need really, the objective is to prepare a synthetic view of the topic for wide distribution. We want to do a synthesis, not to invent new things. The work is structured under small groups dedicated to one topic, typically 10 members maximum per subgroup, from all over the world, of course. The initial topics are quite obvious: terminology, orbit accuracy, data fusion, space capacity management, COLA process, and so on and so on. So this is starting soon. Please stay tuned. Here you see the typical page from the IAF Space Traffic Management Committee. You have the address at the bottom of the page. This is very classical for those of you who work with IAF. We have document categories. So what we need now is just to fill it. And with this, I'd like to thank you for your attention, and I'm ready for any question.